Before we, kick it off and start talking about some elements, I just wanted to check, how's the energy with everyone? So let me ask you a question. You know how nowadays there's an international day for everything? Like there's an international day for coffee, for beer, for, the profession of the medics, whatever. And there's actually a Programmers International Day. Do you know when it is? By the way, have you heard that there is one? No? Okay. It's on the 256th day of the year.
Guess what?
It happens to be
Guess what
September
day it is
13th today. So give yourselves, because I know everyone here is a programmer, give yourselves a round of applause for all the good things that you do. Because, each and every one of us, we do help progress. We do help everyone else to live easier, and we do help the technology to actually develop. And we already got introduced. My name is Konstantin Dinev. I'm Director of Product Development at Infragistics.
And I'm Damyan Petev. I am a product architect at Infragistics. And I swear that's me. I might look a little different. It's not a bug. I figured I should do this as a feature instead of actually doing a proper updated headshot. So that image was actually taken for a conference quite a few years ago, where I did a talk at the very dawn of Angular, and we jumped at the opportunity. And at that point, I was coming out of a fight with AngularJS's digest cycle, trying to force it to wrap AngularJS around one of our other products. And I was done with it. And Zone.js came in, and I welcomed our monkey patching overlord like there was no tomorrow. And now that we're actively trying to go zoneless, that statement has aged like fine milk, probably. Yes. But funnily enough, the predicament that put us in that situation so many years ago is the very same predicament why we're here today. Again, which is taking our product and moving it across platforms.
Yeah, but how did we do that, right?
Yes.
So first of all, we're going to talk about Angular elements. It was in the title, so you probably guessed. First of all, have you heard that there is Angular elements, Angular/elements? Okay, quite a few people know about them. Have you ever used them? Okay. I would like to actually know what the use cases have been, right? And for the rest, what are Angular elements? Well, basically, those are Angular components packaged as standard-based web components, right? So custom elements. All right, and how does this help us, right? We're building an Angular application. We have Angular components. Why do we need them as web components, right? And initially, when Angular elements came out, I wasn't a person who said, oh, I immediately see a use case for this. No. Actually, it took a while, but it was shortly after, maybe, that I was presented with a problem, right? What was the problem? So we've been working a lot and for quite some time on a very large reusable component library, UI component library for Angular. It's called Ignite UI for Angular. And we basically, at that point, had pretty much every component that you can think of, right? From the small things like buttons, chips, menus, whatever, to the really heavy components that can be considered applications themselves, like grids, charts, doc managers, whatever. And so at that point, there were actually requests. So people love the product that we have, but not everyone uses Angular. And so we ship reusable UI component libraries. And there were requests coming in. OK, I need this component, but we do React. What are we going to do with our Angular components, right? Or, yeah, great, but we're a Microsoft shop. We do .NET, so we're moving to Blazor. And Angular does nothing for them, right? We can actually start talking to them, give them some on-the-spot solutions, but no, we do need component libraries for the other frameworks. And so here, I started evaluating options. And the options, there were really 3 of them, were the following. Well, first of all, we can build new native component library for each framework or library that we want to target. Right, great. Second option, well, let's not go that far. Let's build actually generic web components and wrap them for the rest of the frameworks that we don't support. And we're, as I mentioned, we already had a fully developed UI component library for Angular. So we didn't need to build that one again. The third option is, can we figure out a way to reuse the existing Angular components that we have and to ship them for other frameworks, basically to reuse code. Right, and so why did we choose elements? Obviously, we went with the third option. Otherwise, we wouldn't be talking about the Angular elements here. But why did we go with the third option? Well, we did some research, right? And we did some estimations. We did some, preliminary work to determine, okay, what's the best thing that we can do here? And the result was pretty much clear. So the estimate initial for number one was it's going to take us 5 years to build all our grids. I'm not talking all our components, all our grids for all for the 3 remaining frameworks that we wanted to ship for, which were at that time React, Native Web Components, and Blazor. All right, so 5 years with the current team. Well, we're going to be so late to the market that whoever wanted our product in React may not be using React in 5 years, or React may not be around at all, or Blazor. So that's not an option, okay? It's going to take us 3 years to build 80% of the feature set. Still, we'll be very late to the market. How long is it going to take us if we do stuff with Angular elements? The initial estimate was actually very close to what we got as a result. So it's going to take us half a year for the full feature set, with a quarter of the manpower that we needed for full native UI component libraries. Right, and based on that, obviously, we went with the last one, and we eventually got to 3 other products that we have, which are for React, Web Components, and Blazor, that are all based on the code base that we have for Angular. So what are the benefits from this, right? Because obviously, one is time, but there are other things. There are, of course, drawbacks, and the really technical architect here is going to talk about the drawbacks also. But the other benefits are, okay, we now have a single code base. If we went with 4 native products, we would have had 4 code bases. Yeah, they would be on top of one and the same design system. They would have the same behaviors and everything else, but we still need to support 4 different code bases. We're not even going to get the same bug in all frameworks, right? When we get a good bug submitted, okay, that one is Blazor specific, or this one is React specific. It's something to do with the framework, whatever. It's really hard to maintain. Single code base, a lot easier to maintain. And if we get a bug, we fix it across the board, unless it's like something really framework specific, with a single fix. Number 2, that all leads to easier maintenance, right? So it takes us less time to actually deliver whenever somebody has a problem. And again, one code base, we maintain it much easier than 4 code bases, or even 2 code bases if we went with option number 2.
We've got it down to basically CI.
Yeah.
Like push a button at this stage. Angular is fixed, push a button, Web Components is fixed, push a button, React is fixed.
Exactly. And that's number 3. All right, if we went with different code bases, we needed to write new set of unit tests, a new set of integration tests, new set of end-to-end tests. While this way, because all of our code lives in Angular, we can actually fully use the full set of Angular tests. And at the moment, I don't know, like, what is the code coverage of the product? It's like 93% or whatever. And this way, all of this 93% code coverage is persisted throughout all frameworks, right? But at the same time, we have to write a very small set of framework-specific or library-specific tests, which basically test that nothing failed in the CI/CD pipeline. And when we run those components against Angular or Web Components or Blazor or React, that things render and the behaviors are persistent. Okay, So that's actually a huge benefit. That's why I said we got the timing down a lot, and we also got the manpower down required, because we can continue writing features at the same time as we are actually delivering a new product, because we're going off this single code base. And now we're going to tell you how we did it, right? Because what we did, okay, great. But how did you guys do it? Because if you've tried to use Angular elements, you probably haven't gotten very far, or like you've solved probably some niche use cases. But here there's a lot of problems that we ran into initially. And I'm handing it back to Damyan to tell you about this.
Alrighty. So I saw quite a few hands, although it is hard to see with the light shining on your face. So I only saw the front seats raising hands. I realize some people know how elements work, but just in case, we'll cover our bases quite quickly. So what we get is basically a custom elements class that's generated when you call create custom element, obviously. And the main entry point for that is the native connected callback, which basically ties the lifecycle of the web component to a strategy that initializes the Angular instance behind it, tied to the same host element, of course. And then using pretty much what you would get from Reflect component, it's the old component factory still behind it, even though it's not used publicly anymore, or it's still deprecated, I believe. Yeah, but that actually carries the information custom elements requires to get all of the information about, hey, I have these inputs on my component. Those we can turn into custom properties and attributes on that web component. Those are tied, again, back to the Angular instance. And since it knows about inputs, it knows also about outputs. And it just basically, the strategy subscribes and exposes that as a single stream. The custom elements wrapper subscribes to that stream and just dispatches custom events, native DOM events. So that's what Elements gives you out of the box, right? I'll quickly jump through basically what I showed as an example. This is straight from Angular source. Just wanted to show that there is no actual magic behind it, obviously, right? So if ng element is a small extension on top of HTML element, so this is just classic web component, right? And you've got your attribute change that basically goes into set input, set input, set input. Your connected callback that's mainly driving events and initializing the Angular instance behind, and all of the inputs that we reflected for our component get defined as custom element. All right, and then the strategy itself, honestly, I'm skipping quite a lot, but the main gist of it is that initialize that's been called on connected. It takes the component factory, create an instance, store that instance, initialize all of the inputs, all of the outputs, attach it to an application ref. And you've got an Angular component sitting behind that web component. So how about we do a little example? So, and by the magic of this being a Reveal.js presentation, so pure HTML, the very same snippet that you're seeing right there is this component right here. And I can actually show you, oh, wait, no data?
You're not connected to the internet again.
Did my Wi-Fi drop off? That's rude.
I have Wi-Fi.
That's rude. That is really rude. No, it did not. It just failed. Okay. We picked up London just fine. 16 degrees. And if we check Bulgaria, quite a bit warmer. All right. I'm going to go back to New York. Clear sky. Also warmer. Okay. Honestly. Okay. So what I wanted to show you is the snippet above in HTML is the precise snippet that you've seen running. Obviously, I have the exact Angular application, and I just linked the dist main and CSS that it produces. But the main point of this is just a box standard Angular component, right? I have a single weather widget. Its main function is to have a model that's the selected location name. I have a few locations, obviously, I even refactored this morning to use resource instead of effect, because that's what the AI hallucinated initially. There, I also said AI. It's good, right? And its only reason for being is take the name, find one of the available locations, fetch weather data from OpenMedio, and resolve that into the markup. And I also made sure to map out every single version of slight rain, slight drizzle, and shower for coming to London. You're welcome. And the weather decided to show sunny for London at this point.
I think we saw all of those variations
Yeah.
today.
No. I discovered this like 2 days ago when I was debugging it, and it spewed out a code that I didn't have, and it was like, slight drizzle. Sure. Of course. The AI only gave me one of the rain versions initially. So yeah, there's that. And the markup is also very simplistic if we have weather data, display weather data. Otherwise, content would default fallback. And there's a select in there. That's one of ours because I figured it would look fancier in the slides. But what I also wanted to show you is, since this is live and I have an error, oh, I don't know if that, I didn't mention it explicitly. There's an error output on the component that's emitted when it doesn't know the location or the fetch fails, right? So I can go on this, and it says select location London, and I can say, nope. And I will say no data. And it will also say, hey, there's a weather widget something. Like that's just the native add event listener attached to it. Also, yeah, okay, that was zoomed enough. Fair enough. Alrighty. And what we can also do, obviously, is project something out of the box. So, oh no, this will fail. Definitely nope. Wow. Okay. And I got a custom projection content. So, out of the things that work, inputs, outputs, obviously, events, and template projection. Well, no, content projection with the default fallbacks. All right, so the things that are missing. Out of this, it's a great demo. It works fine, as long as you don't need anything more special, and we hit that pretty much immediately with our components. So we've got a hierarchical structure, like we usually have a grid that has columns underneath, it has a toolbar, it has a paginator. Those also have their child components relatively defined in some cases. So it's a heavy structure. Angular elements is giving you like a single element. It's usually created as a root, and that's it. Then our components also have additional public API that's sometimes just public getters. Those are neither input nor output. We have methods. None of those things actually also get exposed. And then the heaviest hitter of them all, we want to template stuff, not just project. And even projection has its own caveats that I'll tell you about in a minute. And then there's the life cycle. Did I mention that the Angular component gets tied to the life cycle of the web component? Well, that works great as long as the web component lives in the DOM. So if the web component ever gets yanked out of the DOM or disconnected, the Angular component dies along with it, which is a bit of a problem when you have components in Angular that can live in the component tree, but they don't necessarily need to live in the DOM. So we had to work around all of those limitations, basically. So we tried, we pushed it pretty far, as you're about to see. We are no strangers to jank, though, so be warned. So yeah, first things first. Reflect components gave us inputs and outputs. That's not enough. We must feed the hungry machine more data. So, first thing, we could have written all of that manually, but nobody wants to maintain that. So we scrapped together a small analyzer that basically goes through our source components, walks through the entire source, pretty much all of the source components. It's TypeScript's compiler API with AST, so it inspects everything, finds basically everything that's component, and I'm glazing heavily out of this. The heavy lifting is in the class that's not visible right here, but it's basically going to every public API, any query that we might be interested, the component, decorator metadata, everything that we might need for data, and then just print out a pretty config for us. So that config, I'll show you a small snippet. For example, we wanted a grid and we want to put columns underneath. So how about, there's a definition for a column. That's the component by reference type, so we can use it later. That's important. We have a selector. We have all of its parents, which are multiple in our case. But let's say, hey, this will be, your grid is your parent. We can have any information about queries. This one doesn't, but for example, the grid itself will have a query, like a content query for its child columns. So we know about that as well. We have additional properties and methods, and we also have templates. We also did a few Boolean coercions that are technically no longer needed, but that predated input transforms. So there's that. So, shopping list. Out of the things that we want to do now that we have data. We want to handle our component structure, so we want, technically, our component wants to inject stuff that are provided by the parent grid, so we need to more or less restore the injector hierarchy Angular would normally give us manually. So that's fun. And we also want our queries to work. And we also want our additional APIs, and we want our templates. In our case, since we're exposing a web component, and we've had great experiences with lit, and lit HTML is very simple for templating, we chose to expose our templating as lit, which means we also need to translate or a way to hook lit templates into Angular as well. So that's also fun. And then some very niche lifecycle adjustments that I might actually skip because we'll probably go over time. Yeah, so there's that. All right, so first things first, when you create an Angular element, you can actually provide a different strategy than the default one. And that's the first entry point for us. We created a custom strategy extending the default one. The extend asterisk is not a new JavaScript syntax. That's me saying it technically extends the default Angular one, except it's not public API. So we extend a copy of our own. There's that. All right, so obviously we have the same initialized component that we normally create from the component factory, except this time we're doing more work. Obviously, this strategy is initialized with our pretty config, so we know, hey, this is the config for this component. It has these parents. We can fish out their selectors and go look into the DOM, pretty much, and find our closest available parent. Out of that parent, we can say, hey, I want to wait for you to have an ng element strategy that will create your component ref. I want that component ref, and I want the injector out of it. So that's our parent injector. And we can use that to create our child component instead of what normally happens, right? And then also, since we have the parent, we can figure out, are there any queries from those parents that are relevant for us? If so, we can find that parent and schedule an update on its query. That's technically not a requirement, but it's kind of harsh to do an update for every single child since each element initializes on its own. It's unlike what Angular would do normally, which is when your parent is created, all of the child instances are pretty much instantly created one after another. And on your view unit, you have everything ready, which is great. In this case, it's actually the other way around most of the time. And these load all asynchronously because they have to wait for their parent to initialize first so we can get an injector, which is all backwards, but that's how it happens. And then also, since there are 20 columns, for example, we don't want to change the parent 20 different times and have it render, 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 render. That would be ridiculous. So we schedule them all on a single queue, and when the last one loads, we update the parent. So at that point, we're going to go, hey, I have a grid. Now I can have columns. And those are all heavy configurational objects, and they have real implications, like I can be sorted, resized, summaries, right? So, out of that, again, by the virtue of this being an HTML presentation, here's the resulting component out of that snippet. So I have a grid, and I have all my columns. They're resizable, they have summaries, and so on and so forth. Right? Step 1 complete. Next on the shopping list, we want additional APIs. That's actually the simpler version. If we have create elements, let's extend that as well with another create of our own that basically calls the original, but with our own strategy and config. And out of that, again, pick out the config, read out all of the additional methods that we've described, extend the prototype, read out all of the additional properties, extend the prototype. Or basically define property is what elements does out of the box. So when we can do that, we can also do, hey, I want to call a method on this grid. And that's pretty much what I'm going to show you. Oh, I managed to run the buttons above the subtitles. That's great. All right, so I have a method. Just select the first 2 columns. Deselect the first 2 columns. Simple, right? Except it took a while to figure out how to do that, but of course, yeah. And then the template wrapper is probably one of the sneakiest ones, but I'll show you just the gist of the implementation. Since we have a strategy, we can also overwrite the set input, and we can check, hey, is that a property that's supposed to be a template? If so, it doesn't set to the instance. We actually have a separate dynamically created template wrapper, which is another Angular component, that's just created when you need a template. And its job is to take a list of functions, so those would be what lit.html uses. And then for each of those, we need an ng template, so we can get a template ref. We need something in the DOM to connect lit to, because lit renders in the DOM directly. So an empty display, pretty much div container, and then pretty much take the context from the template, render inside. And that template ref that you get out of the ng template itself can be assigned to the Angular component. It will render this willy-nilly, and since it's rendering it and the lit call is in the template, it will also call lit render every time it wants to render a template. And we get templating out of it. So in that case, as an example, I'll grab lit from HTML, and one of our columns is in stock, and weirdly, some of the items are barely in stock or not at all. So we can highlight those. If we say if the value is less than 20, highlight. And that's the whole Frankenstein thing combined. Yeah. Alrighty, alrighty.
But we're not done yet.
Yeah. Well, there's more to it than that. I've skipped quite a few workarounds, probably, but there are things that we want to do, like lifecycle stuff. I explained why it's the links between the component itself. Our columns normally don't live in the DOM, but because elements need that, for elements specifically, we project those in the DOM as well. There's also the issue with them being destroyed randomly if they decide to go away. That's a different story. The other thing is packaging. We're basically creating a component library, but element is tied to an application build. For the moment, I've spoken to people from the Angular team. I've gotten interesting replies. Maybe module federation could help. I've seen the analog version of a Vite plugin that Vite might help as well. And the last thing on my list that Vite can also help potentially is differential compile, because we have things that are specific to elements, unfortunately, in our source, and we want to drop those. Insert anything else you can think of. But besides the wish list, this has helped us tremendously to build out products quicker and ship them for years without spending all of that effort to rebuild them.
True, Damyan. So it helped us a lot. We built, our code generation platform with it, and that allowed us to be able to produce not just Angular from it, but that ability to produce also web
If you've been
components,
to the booth,
React, and Blazor, right? Because we were able to so quickly deliver this library. We're out of time, so we're going to skip the questions. But me and Damyan is still here.
Yeah.
So if you have any questions on top of what we were just showing, just come to us, and we're going to answer all of them. And thank you.
Oh, yeah. Twitter links, Ignite Angular/projects elements is where you find all of the stuff I showed you in terms of code that we do. And this presentation lives right there. Thank you.